Hello, our community members. I think at this time it's a morning where I am, and it should be around 12 p.m. in Zimbabwe. I always take a walk as part of the daily exercises. Sometimes it's necessary, especially for people who work with computers. You end up spending more time seated. So this is a basically ordinary street. You can see the environment is more or less out of the city. Besides, I prefer living in areas that are more or less like rural. Even when I'm in Zimbabwe, I prefer living in our rural villages, out there in the rural areas. It's quiet, and you can think, even in the heat. Last week I was in Zimbabwe. I managed to drive from Harare to Uzumba, from Uzumba to Masvingo, where passed through Mashava, went to Zishavane, and then I only had time to go back again through the same route when I came back over the weekend. Right. This recording is just a short recording where I would like to just explain how to state a research problem. So as such, this recording is directed at members of our community who are in the process of defining a research problem, whether for doctoral research or for just your own research, because you need to define it before you actually start it. You need to define a research project. So what I'm going to explain applies to those who are defining a research problem for PhD or for just doing research. Right, at the beginning, at the very start, or after you have done a little bit of scanning of the literature for purposes of identifying a research gap. Now assume you have found your research gap. How do you state it? How do you say it to people so that it starts making sense, especially to researchers or to your senior researchers when they read it? What are they looking for? What are the elements of a research problem? That is very important as for during the training of a researcher, to know how to state a research problem. When you get it, I'm assuming that when you are trying to find out, okay, what am I going to research about? You do a literature review, but not a comprehensive one, but enough to establish a gap. Sometimes you only need to collect about 10 papers, most recent papers. Apologies, I am walking in grass and I have hay fever. Right, assume you have done a literature review. Usually you collect literature review papers, because literature review papers will review current state of the art. So you look at a 2023 paper, if you are doing it at the time of my recording here. You look at works, literature review papers that have been published in 2023. These are the most recent. In the area, you need to narrow down. Find a way of saying, okay, I want to go into this area. And then you get literature review papers in that area which are sufficiently broad to give you a broad overview of the domain of the terrain. Zvakafanana kuti uchitsvaka mombe kazhinji. Mazuva taigara kumaruzevha uko tichitsvaka mombe mumashanga, nguva yamashanga iyi, kana munguva yechirimo. Handizivi kuti mamwe madialects edu emuZimbabwe vanoshandisa shoko rokuti kumashanga isusu kumasvingo tinoti kumashanga kana kuti muchirimo. Right, mombe dzinoregwa dzichiinda. Then munozodzitsvaka. Although mazano ndakazichinja pamusha pangu nekuda kwekuti ndakazoisa mvura. Saka tongoisa mvura ndikabuilda ka container in the ground where we pour water and the cows come back. Saka zvikomana zviri kumba havachandotsvaki mombe, but isita inotsvaka nekuti kwakusina mvura. Dzadzingauyi dzoga. Saka ndainotsvaka mombe. Taikwira either pagomo kana kuti one of the tallest tree in the area. Wotarisa area wose kazhinji muchirimo musina mashizha, hauna obstruction, and you must have a good eyesight yekuona kuti mombe dzangu idzo. Right, kana kuti unoona kune mombe even usingadzione hako. Saka unokwira either mugomo kana kuti kwedu hakuna makomo akawanda, saka ukawana chikomo 1. Kana kusina, it is flat, you can climb a tallest tree. Wowona the terrain, wowona kuwe area ane mombe, wozoplota route yako after that. Similar to that, when you are looking for a research problem, for research, either for doctoral or just a research project, you do that literature review. You go to one terrain, what are the issues, what is being currently investigated. The my problems are which causes sleepless nights, because it's true that these guys don't sleep, especially my Chinese. I've worked whether very China, Europe, every university, my Chinese students ndo varipo havavati. Mangwana unowana varipo vagopedza the cities the whole day. Unovata pa desk. That's what these guys are doing. That's why vakuita technology dzimwe dzamunoona idzi. Havavati. These Indians vari kuinda kumunda handiti. They don't sleep. Right, of course the assumption namu yedu yekuZimbabwe ndeyechikafu. But when you are looking for a research problem, you find the gap. But when you find the gap, you then should do another comprehensive literature review. Kunyatsoita refine. Kunyatsoita refine. Why it refine? You need to now reach a stage where you have enough information to say it. You have enough information to state it. The question is, how do you state it? This is what I would like to cover. It is right. Normally, when in a statement of a research problem, you need 3 things. I think in our last meeting, these are people working on roads and all that stuff, right? Road maintenance here, and maybe something like drainage system. Saka, you need 3 things. First, you need to state exactly what you are investigating, but when you also need to state what you will need to be able to do once you solve that problem, right? Then, once you are able to do that, you need to state the second thing, the third thing. How will the world change after you have solved that problem? Right, so there are 3 things. The research problem, that one must be in your area. It must be in computer science, for instance, or in information systems, not in the domain of the application of the solution. For instance, some information system solution can be applied to business. So the business problem that will be solved when you have solved your information system problem is not your research problem. So there are 3 things. I call them X, Y, and Z. And when you put X, Y, and Z in a sentence, you say, I'm investigating X in order to be able to do Y, so that we will then be able to do Z. Right. In other words, to get Z, you need Y, And to get y, you need a solution to x. Right? You need x to be solved. So I am investigating x. In order to, once I solve it, I will be able to do y. But once I'm able to do y, then we will be able to do things like z. Then z can be a set. Usually z can be, you can pick one, yes, but you could be able to do y. It's similar. A typical example is that when you talk of it, the guy who developed the DBMS, the database management system, for the first time, they were faced with data and they needed to query it. They first needed to record the data in a way you could unozongoiwana even 100 years ago later, on a database really faithfully storing what you gave it. And then later on you want to be able to retrieve, to do the CRUD operations, if you know. CRUD operations include querying, the ability to query it. So this guy was saying, I want to develop a mechanism or an approach to managing data that correctly represent the world. But at the same time, I want to be able then to retrieve, to update it and be able to query it. Right. So I am investigating a way to store data in a way that will be able to manipulate it. To manipulate it and manage it. Right. But so the X is investigating a way to store data. Right. A mechanism that allow him to store data. This will then allow them to manage all the, to store data and query it and all that stuff. But once that has been achieved, then we can, in our various domains, like agriculture, business, we will then be able to store all the data and query it and do all that stuff. Right. If you state it like that, you can identify the X, the Y, and the Z. Right. And no one will then ask you a lot of questions. So you say, I want to investigate this concept here and solve the problem. This problem here. This problem of storing data, for example. And then I want to be able to once we do that, we will be able to query data, update it, store it, or no. Right. Once we are able to do that, we will then be able to manage a business with this data, or create accounting systems which then have data stored in a permanent way, and also be able to modify it and all that stuff within the context of the business world. Right. So we have X, Y, and Z. Right. If you can state it that way, most senior researchers will nod their head to say, oh, there is a research problem. Now, the question is, which domains are X, Y, and Z? Right. X is the problem, the research problem. It must be in your area, right? In your computer science area. And that's what you must spend time explaining to people, for them to understand the X. Y is easy because once it will be clear that once you solve this one, you should be able to do this one. But the question now is, once we are able to do this one, so what? That's when you now pick the application domain. There can be many of them. For computer science, it's many. Like database systems, you can use them in agriculture, you can use them in healthcare, you can use them in accounting and all that. So the application domain, which is Z, can be anything. Right. It's normally it's a beautiful problem if you can apply your results of your research. If you apply Y in a variety of domains, then your PhD is very beautiful. The problem is a beautiful research problem, because a beautiful research problem will give us a generic, you research a problem, come up with a solution. That solution is generic and you can apply it in various areas. So it will be a very beautiful solution. A beautiful solution in research is one that gives you a concept or knowledge that you can apply in many domains. A typical example of a beautiful concept that was developed is the concept of beauty. The concept of beauty. You can use the word beauty to a flower. A beautiful girl, you can apply it to a girl. You have a beautiful flower and a beautiful girl. But the flower and the girl are different. How come we can use the same concept to two completely different things? That's a beautiful concept. I mean, yeah, if you can come up with a PhD solution that can be applied to different things, which between themselves, if you look at them, they are very different. But your problem, your concept, the solution you have developed from your research applies to all those situations, which are completely different from each other. Right, like a girl and a flower. A flower grows as a plant, grows on a plant. A girl is a complete mammal, a human being, a mammal. But we use the concept of beauty. So that concept, from a research perspective, that's what you want to achieve in your doctoral problem. Your doctoral problem should come up with a new concept, a new solution that can be applied to different problems. So this is the why. This is the y or the x. If you have a solution to x, which allow you then to do y, and y can then be applied in a number of areas, then you have. So in your problem, find the x, the y, and the z. And when you say it, this should be clear. And one then should be able to tell that x is either in computer science, software engineering, information systems, and y. X and y should usually y is sort of generic tasks that you can do, like search, kutsvaka. So it's a generic task that can be applied to different objects. You can talk about banana, my tomatoes, my toki, and all that stuff. The task you could search can be applied to anything, right? So if you can if the problem is to find an algorithm, to investigate a way to quickly search through something, and then the task of searching can then be applied to almost anything, and then you can apply your research to basically anything, different objects. So that's a very beautiful concept. So in your case, whatever problem you are looking at, whatever area you are looking at, find X, Y, and Z. It takes a lot of effort to do that. Usually it's just literature review. Read a lot of literature, and then when you reach a stage where you nail it down, here's my problem, then you need to split it into X, Y, Z. Right. So I think that's in a nutshell. That's what I want to say. Most people will specify Z. That's why some people will start talking about agriculture, everything in agriculture. Sakai wakaita degree agriculture iri zvanoda kuita research agriculture. Nokuti ari kuspecify Z. In that X is your area. Y is a generic task, something you'll be able to do once you solve X. And then once you have Y, you are able to do those things, then you'll be able to solve certain problems in various domains, right? Which is the Z. So don't specify the Z. When I look at it, in my case, I see, we're going to another healthcare, disease, and all that stuff. But then that's not the area. I'm not going to train in healthcare. And you don't want to try to get your degree in healthcare, isn't it? Yeah. Of course, I know why you guys are doing that. Because Itai research, solve our problems in Zimbabwe. We can still do that by specifying X, Y, and Z. Because the Z is the Zimbabwean problems. The Z is the Zimbabwean problem. So you need to find a way to generic. You can be inspired by Z. I'm not saying the path to finding X, Y, and Z is to start from X. You can start from Z, which is the domain like healthcare, and then go back to find Y and X. It doesn't matter how you found it. It could be inspired by Z. X and Y could be inspired by Z. But you have to find them. But when you say them, someone will not know that you got it from Z. You all should not know, because you know how to state it. So that is important. In other words, be inspired by the application problem. We call it a motivation problem, a motivating problem. But the motivating problem is not the research problem. You will need then to work out, to think hard, research, and find the motivating problem. So that is important. So that's of course you need to do a lot of work before you come to a stage where you state your problem. Unfortunately, most of you guys are writing your problem without doing any literature review. So you don't even understand what the problem you are trying to state. So, okay, when you are trying to register, find a supervisor. That's what your senior researchers have been saying in our previous meeting. Find someone or a senior researcher to work with where you can, but of course our community does that. And some of you may not find the easy time to present. You could record videos like this one where you want to explain your research problem, and we can listen to it and comment on it. So I suggest you do these short recordings. Right now I'm at 21 minutes. Probably it's too much for some of your data, but if you're on Wi-Fi, you can watch some of these videos, snippets, and be able to explain the situation. But you can, in Zimbabwe we say, you must do relevant research to the country. Be inspired by the problem. It could be in agriculture, in healthcare, in our rural areas, in our farms, in our whatever. But those areas are not computing. You must then find within that problem, inspired by that problem, find the X and Y. And when you say it, you can basically say it without even mentioning that you were inspired by an area in healthcare or something like that. So that is the problem that you want to that's how you want to do it. Because if you are in front of a panel, whether it use it or not, they will always ask, you are in computer science, where is the computer science in your problem? And usually people get stuck. They get stuck to say, oh, where is the computer science in my problem? And I've had students who have been asked those questions when they come in front of a panel. Even when if your supervisor doesn't, you are not properly trained, you may end up writing a thesis in agriculture or a thesis in one of the domains. When in fact, if you want, that is usually the case study. That's where you test that your research is successful. It works. If it works, it must go into the field. So you deploy it and make sure that you show that it works in agriculture, it works in healthcare. So that's not, but the healthcare domain is not your area. Your area is, you must come up with a conceptual, with a contribution to your domain. So that's, so by saying you need to focus on computer science or on your computing or information system, we are not saying that you should not be problem oriented. You should use that as a case study or be inspired by it. Start with the problem in agriculture, go to agriculture, find the challenges they face, come back and then rediscover where the computer science is, where your computer science or information technology. Unfortunately, I'm mentioning more computer science, but that's not my intention. My intention really is to say that whatever domain you are in the area of computing, information systems, software engineering, IT, computer science, that's where your problem should be, such that when you are talking to somebody, they can easily tell that's where your problem is. But use the domain problem as a case study where you test whether your result works in the world. That's what Zimbabwe needs. People who are inspired. Our research is relevant if it's inspired by the problems that we face. But then when we research in the areas of computing. And then once we find our solutions, we now go on show that it works in the real world. So we do need to be inspired by the problems. But those problems are in different domains from ours, and we are not really interested in them. So with that, my intention was to record a 25-minute video on this. Unfortunately, because I recorded this when I was walking, I didn't show you a diagram, but the diagram should be you need X, Y, and Z. But anyway, I think I will do another video with a diagram that shows you exactly how to think, how to be able to say a problem, to state a research problem in such a way that people won't ask you much. So with that, good luck. I think my next recording will be say, how do you find a research problem? Because this video was assuming you have found it. Now you not need to state it. Finding it is a different matter. That's what most people probably also have a challenge with. Okay, good luck. Bye-bye.